Okay, welcome to the CAS calculator part of this tutorial on systems of simultaneous equations. And we're going to use the two examples we saw before on the whiteboard demonstrations to have a look at solving those two equations by the CAS. So the first method to solve simultaneous equations would be to simply type in our equations. Now, there's a couple of different ways to do this. We can actually just set up the two equations using text and a solve with an AND statement in between. So solve x plus 2y equals to 1 and solve 2x plus 4y equals to 3. And we want to solve those for both x and y. And you'll see you got an answer of false. So immediately you can tell there's no solution for those particular cases. Another way to set up these equations, and it might be useful if you have more than two equations, is to again use the solve command. But this time open up using the templates here a set of equations. So the ones we're looking for here are multiple equations, and we'll be asked how many equations we want. So we have a system of 2, 3, 4 multiple equations. This time we're just going to use those two equations as before, and we're going to type them in. And you can see you type them in a row. So we're going to have to set up the same equations here, plus 4y equals to 3. Just come across, so you're in between, and comma x, comma y. Now, as I said, if you had a series of 3, 4, 5 multiple equations, that's a nicer way than rather than writing it from left to right and going up the screen. And again, we'll come up with false. Now, we want to look at the alternative ways of solving these using matrices. So we looked at what was the A matrix, the X matrix, and the B matrix in the whiteboard tutorials. So we can actually define those matrices. So remember, A equals to, or A dot equals on the keypad over there, or you can type define if you wish. Now we're going to need a matrix. This will be a 2 by 2 matrix. So again, we come across to our templates, and we'll have our predefined template 2 by 2 matrix, and our coefficients here will be 1, 2, 2, and 4. We will also need the B matrix. And again, if we use our templates this time, we have this particular option, which is obviously 2 rows and 1 column. And our values here are going to be 1 and 3. So once we have those, we can actually find a solution to this equation by matrices. So we need the inverse of A, so A to the power of negative, wrong negative sign, negative 1, come across, multiplied by our B matrix. Now you see both A and B have gone bold there, meaning they're predefined, and we get an error message saying we have a singular matrix. So what that means is we've created an error in the process and we can't find a solution. So if you're trying to solve these by matrices, that's the error message that you'll get, and that will actually be caused by just this preliminary stage, A to the power of negative 1. Again, you get a singular matrix. Or if we find the determinant of A, you will see there that the determinant is 0. And that's what's causing the problem when we try and find the inverse of A. We're getting a singular matrix because our determinant is actually equal to 0. Another clever way to actually quickly find what types of solutions we have is to use what's called the ref command. Now we find that under menu, matrix, and vector, we want the reduced row echelon form. So RF, RREF, and you can just type RF on the screen if you wish. Now we're going to need a matrix again, and this particular matrix that we want is over here, where we can choose any size matrix. Now we're going to want 2 rows, and we're going to want this time 3 columns. So after we have 2 rows and 3 columns, again we get our template. Now the left hand 4 values will be our A matrix. So we're going to have 1, 2, 2, and 4. So that's our A matrix. We don't have our X matrix, and we come across here and we put our B matrix. So the constant values here of 1 and 3. Now the CAS will try and reduce this down to its lowest common denominator, so to speak. Okay, and when we come up with this particular form, we find the first row is telling us that X plus 2y equals to 0. Well, okay, that's got a possible solution. But the second row is actually telling us that 0x plus 0y, so I'll type it on the screen, 0x plus 0y is equal to 1. Now that would reduce down to a statement that said 0 equals to 1. And as you can see there, that's nonsense. That's a false statement. So we have no solution to those particular equations. So out of all those methods there, either trying to solve and interpreting the false statement, putting in the determinant, recognizing the determinant is equal to 0, or the best method here is to create this combined matrix where you have both A and B and reduce that row down. And when you find 0, 0, 1 or 0, 0, any number there, you will have no solution for this particular set of equations. So there it is. That's no solutions or parallel lines using the Cas technology. The next tutorial will deal with coincident lines and infinite solutions.